Hi everyone, welcome to my channel. In this video, I will show you how to create AWS site-to-site VPN and access VPC resources from on-site data center. Let me quickly introduce about myself. My name is Thiru and I have over 20 years of IT industry experience. And I'm also an AWS community builder. And these are the AWS certifications that I have achieved in the past. And I'm also an ex-AWS partner AI/ML Black Belt and ex-AWS partner ambassador. I think that's enough introduction about myself. Now let's quickly see what AWS site-to-site VPN is and its benefits and use cases. AWS site-to-site VPN is a fully managed service that creates a secure connection between your data center or branch office and your AWS resources using IPsec tunnels. By default, an instance that you launch within an Amazon VPC cannot communicate with your own remote network. You can enable access to your remote network from your VPC by creating an AWS site-to-site VPN connection and configuring routing to pass through the connection. When using site-to-site VPN, you can connect to your AWS VPC using AWS Virtual Private Gateway or Transit Gateway. 2 tunnels per connections are used for increased redundancy. For globally distributed applications, the accelerated site-to-site VPN option provides even greater performance by working with AWS Global Accelerator to intelligently route your traffic to the nearest AWS network endpoint with the best performance. Now let's see some of the benefits of AWS site-to-site VPN. First, it's highly available. AWS site-to-site VPN delivers high availability by using 2 tunnels across multiple availability zones within the AWS global network. You can stream primary traffic through the first tunnel and use the second tunnel for redundancy. If one tunnel goes down, traffic continues to flow. Secure. AWS site-to-site VPN is highly secure. With AWS site-to-site VPN, you can connect to an Amazon VPC or AWS Transit Gateway the same way you connect to your on-premises servers. AWS site-to-site VPN establishes secure and private sessions using IPsec. Accelerate applications. The accelerated site-to-site VPN option improves the performance of your VPN connection by working with AWS Global Accelerator. AWS Global Accelerator is used to intelligently route traffic to the nearest AWS network endpoint with the best performance. Robust monitoring. AWS site-to-site VPN gives you visibility into local and remote network health and monitors the reliability and performance of your VPN connections by integrating with Amazon CloudWatch. Now let's see some of the use cases of AWS site-to-site VPN. First, application migration. Moving applications to the cloud is easier with a site-to-site VPN connection between your network and the AWS cloud. You can host Amazon VPCs behind your corporate firewall and seamlessly move your IT resources without changing the way your users access these applications. Secure communication between remote locations. You can use AWS site-to-site VPN connections to securely communicate between remote sites. Now let's see some of the prerequisites to create AWS site-to-site VPN. First, customer gateway device. This is the physical or software device on your side of the VPN connection. You need the vendor, platform, and software version. This is the device that is on the on-prem or customer remote site. Next, customer gateway. This is the logical device that we create on AWS side for the customer gateway device. To create the customer gateway device resource in AWS, you need the internet routable IP address for the device's external interface. That's the public IP for the customer gateway device. And we need the type of the routing. It could be either static or dynamic. In this demo, I will show you how to create AWS site-to-site VPN using static routing. For dynamic routing, the border gateway protocol ASN is required. And optionally, you will need private certificate from AWS Private Certificate Authority to authenticate your VPN. And optionally, the ASN for the AWS side of the BGP session. You specify this when you create a virtual private gateway or transit gateway. If you do not specify a value, the default ASN applies. Now let's see the steps to create the AWS site-to-site VPN. First, we have to create a customer gateway. A customer gateway provides information to AWS about your customer gateway device or software application. If you plan to use a private certificate to authenticate your VPN, create a private certificate from a subordinate certificating authority using AWS Private Certificate Authority. Step 2. We have to create target gateway. To establish a VPN connection between your VPC and your on-premises network, you must create a target gateway on the AWS side of the connection. The target gateway can be a virtual private gateway or a transit gateway. Step 3. Configure routing. To enable instances in your VPC to reach your customer gateway, you must configure your route table to include the routes used by your VPN connection and point them to your virtual private gateway or transit gateway. Next, update the security group. To allow access to instances in your VPC from your network, you must update your security group rules to enable inbound SSH, RDP, and ICMP access. Depends on what you need to access. Next, create the VPN connection. Create the VPN connection using the customer gateway in combination with the virtual private gateway or transit gateway that you created earlier. Next, download the configuration file. After you create the VPN connection, you can download a sample configuration file to use for configuring the customer gateway device. And configure the customer gateway device. We can use the sample configuration file that we have downloaded in the previous step to configure the customer gateway device. The customer gateway device is the physical or software appliance on your side of the VPN connection. And finally, we can test the VPN connection. So these are the steps to create AWS site-to-site VPN. I will walk you through each step in this video. Now let's see the AWS site-to-site VPN architecture. And we have a corporate data center on the left and we have AWS on the right. And we have a VPC created with 2 availability zones. And so I have created 2 public subnets and 4 private subnets. And I have created an Aurora database in this. And first I will show you how we can connect, how we traditionally used to connect to the databases or any VPC resources from the corporate data center using a Bastion host or jump box. And then I will show you how to create the AWS site-to-site VPN and how easy and secure it is to connect VPC resources, that is the Aurora database, from your corporate data center using private IP addresses without going to the public internet. So in this architecture, I have created a Bastion host or jump box in a public subnet. and I have created a private EC2 instance on a private subnet with no public IP address, and I have created Aurora database on a private subnet. So I have already created the VPC resources that I have shown here. If you need to know how to create Amazon Aurora database in a custom VPC, I already have a video for that in my channel. Please check it out. I'll give the description link in the description as well. So this is how we will connect. Like, we will connect from our local system, and we will first connect to the jump box, and then we'll connect to the private EC2 instance from the jump box, and then we will access the Aurora database. This is how we usually access the VPC resources or the databases that is on the VPC side, AWS VPC from our corporate data center if we don't have a site-to-site VPN. I will show you how the architecture will be simple in the next slide. See, now we don't need to have any public subnet or any EC2 instances on the Amazon VPC side, AWS side. Like, we can connect, we can create AWS site-to-site VPN and access their database from our corporate data center using the site VPN connection. So first we need to create that VPN gateway that is highly available. We'll have 2 endpoints in 2 availability zone. So VPN gateway is highly available. And we'll have the customer gateway. And since I don't have any data center on-prem data center, what I'm going to use is I'm going to use AWS VPC in another region, and I will use a Strong Swan as a VPN customer gateway device. Strong Swan is an open source IPsec VPN, and then we will establish the 2 tunnel. We'll configure 2 tunnel. Once we configure the AWS site-to-site VPN and both the tunnels, and we can access the database from our corporate data center directly. We don't need any public IP addresses. We don't need anything. We can access that VPC resources securely using AWS site-to-site VPN. This is the architecture we will achieve, and I will show you how we can do that step by step. So I think that's enough theory. Let's log into the AWS console and I'll walk you through the process. Okay, I have now logged into AWS console, and let me walk you through the VPC resources that I have already created. Let me go to VPC, and let me show you the VPC that I have created. So this is the default VPC, and I have created a VPC named AWS VPC, and I can show you the resource map, and it has 6 subnets and 2 public subnets and 4 private subnets and 2 availability zones, US East 1A and US East 1B, and the route tables and everything here. And if you see the CIDR range, it's 10.0.0.0/16 is what I have used, and I have created this VPC in US East 1, that is the North Virginia region. For the on-prem network, I'm gonna create a new VPC and a new region. Maybe I'll use Oregon, US West 2, and I'll walk you through the process. Before we do that, let me show you the EC2 instances that I already have. So I have created 2 instances as I had shown in the architecture diagram. I have created a Bastion host, and this will be our jump box. We will SSH to this instance, and we will SSH from this Bastion host to the private EC2 instance and then access the Aurora database. And if you see, the Bastion host has a public IPv4 address and a private address. But if you see the private EC2 instance, it doesn't have any public IPv4 address. It only has private IPv4 address, and we have created in a private subnet. And let me show you the RDS database that I have created. So this is the database that I have created, and this is the database endpoint. And if you see, this is actually private. It doesn't have any public access. It is not publicly accessible. So it only has we can access this one only from our private network from VPC, or like we can access this one after we create the AWS site-to-site VPN. First, let me show you how we can access this one in the traditional way, like SSHing to the jump box and then the private EC2 instance and then accessing this database, and I will show you. So I'll keep this on the left and my terminal on the right. Let me go to instances and click on Bastion host, and I can copy the public IPv4 address and I can SSH to it. And I have already added the SSH key, so I'm going to use SSH agent forwarding. So I have SSH to the Bastion host. You see, this is the private IP address for Bastion host is 10.0.6.10, and we can verify that here. Private IPv4 address for this one is 10.0.6.10. And now let's select the private EC2 instance and copy the private IPv4 address and SSH to that private EC2 instance with the private IP address. So now we have SSHed to the private EC2 instance. You can see the IP address is 10.0.135.24. That's same 10.0.135.24. We are now on the private EC2 instance. Now let's access the database. Let's get the endpoint RDS. Let's copy the endpoint and port is 3306. User admin. Sorry, I have to give the password. Now I have connected to the Aurora database. See, I have created a database named company. Let's access it. Show you the tables. I just created a sample one, so I'm just showing this one here so we can verify that once we created the AWS site-to-site VPN connection and then access the database from our on-prem server, and then we can verify the connection and then check this out quickly. Products. That's good enough. So this is the architecture that I already created on the AWS side. So I also showed you how we traditionally access the database from our on-prem server. Like, we need to go from on-prem server to the jump box, that's the bastion host, and then to secure the database, we keep it in the private subnet, and then we don't want to access it from the jump box. So from the jump box, we connect to the private EC2 instance and then access the database. But once we create the site-to-site VPN connection, we don't need the jump boxes or the any EC2 instances. We can access the database from our on-prem server directly. Okay, let me quit this one quickly and also go to VPC in a new window. Let me change the region to Oregon. This is where we are going to create or simulate our on-prem environment. Go to VPC. I'm going to create a VPC. I'm going to name it on-prem DC. That's for on-premises data center. And I'm going to use (192.168.0.0/16) CIDR block. And for the availability zone, for the on-prem side, we don't need a multi-AZ. I'm just going to create one availability zone. This is just for the demo purpose. And for the number of public subnets, I'm just going to keep one, and then I don't need any private subnets. Even though we have the instances on the public subnet here, and we are going to access the VPC resources using the private IP addresses from our site-to-site, using the VPN connection. And we don't need any NAT gateway here, and I don't need any VPC endpoints. I'm just going to create a simple one. It will be real quick. Okay, it's ready. So the on-prem DC VPC is created in Oregon region. Now let's quickly create two instances. One for our customer gateway device. So that's where we will configure strong swan. I'm going to use a strong swan for the customer gateway. That's open source IPsec VPN. Let me go to EC2. Make sure that we are in Oregon region or whatever the region that you want to use for your on-prem data center. Go to instances. I'm going to launch an instance. So first instance, I'm going to name it as on-prem router. And we're going to use Ubuntu. I'm going to use the key pair that I already have. For the VPC, let's select on-prem DC. And subnet, we just have only one. And for auto assign public IP, we need to enable this one. If you remember, we need the public IP address to create the customer gateway logical device on the AWS side for a VPN connection. So I'm going to enable this one. And security group, I'm going to create a new security group. I'm going to name it as on-prem router security group. I'm going to use the same for the description. And for SSH, for now I'm going to leave it SSH with a open anywhere from 0.0.0/0. I'm not going to use customer my IP. I will delete this instance once the demo is done. So I'm going to keep it open with a 0.0.0. And everything looks good. Let's launch the instance. It's getting created. Once it's getting created, let's go ahead and create another instance for on-prem server. For on-prem server, I'm going to use Amazon Linux and Amazon Linux 2023 AMI. And for the keeper, I'll use EC2 keeper, and I'm going to select the VPC on-prem DC and the same subnet. And again, I'm going to assign public IP address. So this is for us to SSH to the on-prem server. But if you don't enable a public IP address, if you only have a private IP address, we can do it like using we can create an endpoint and then we can connect to it. Is to instance connect endpoint. And if you want to know how to connect to EC2 instances with a private IP address using EC2 instance connect endpoint, I already have a video. Please check that out in my channel, and I'll give the link in the description as well. For on-prem server, I'm going to create a new security group. I'm going to name it as on-prem server security group. For the consistency, I'm going to use the same for the description as well. And for SSH connection, so I'm going to leave this rule SSH from anywhere, so I can SSH to this instance quickly from my system. And I'm going to add another security rule. Here I'm going to say all traffic, and source type is custom, and I'm going to select on-prem router security group here. So I want to open all the traffic that comes from the router security group for the simplicity purpose. And everything else looks okay. I'm going to launch the instance. Okay. So we have created two instances, one on-prem router with a public IP address and private IP address, and same here on-prem server with a public IP address and private IP address. Now let's let this instance configure. So they let the initialization complete. I'm going to go to my other console where I have my AWS VPC resources created on US East 1 region, and I'm going to start the AWS site-to-site VPN connection. Let's go to VPC console here, go to customer gateways. Let's create a customer gateway. And I'm going to leave that ASN, the default one. For the IP address, we need the IP address of the on-prem server. So on-prem router. So this is the on-prem router that we have created on the Oregon region. I'm going to copy the public IPv4 address. And I'm going to leave the certificate ARN, so the default ones. Create the customer gateway. And next, let's create a virtual private gateway. So let me name it as PG1, and I'm going to leave that default Amazon default ASN. So let's wait for this to get created. Once it is created, we can attach it to our AWS VPC. So it's created and it's in a detached state. So select this one. Actions, attach to VPC, and select AWS VPC. It is attaching. So we can wait for this one to get it attached to the VPC. It won't take much time. And next we need to create site-to-site VPN connection. So let this go on, and let me go into this one here. I'll show you how to create VPN connection. For the VPN connection name, I'm going to use name it as AWS on-prem VPN, and I'm going to use the target gateway type as the virtual private gateway for this one, which we have already created. So it is attached already. And customer gateway, I'm going to select the customer gateway that we have created already, the existing one. And for the routing options, for this demo, I'm not going to use dynamic. Maybe I'll do a separate video in the future for dynamic VPN routing. For this demo, I'm going to select static. And for the static IP prefixes, we can add the two prefixes that we have, one for the on-prem and one for the AWS side. So for the on-prem, it is 192.168.0/16. And for AWS side, it's 10.0.0/16. So I have added the static IP prefixes. Next, let's go to local IPv4 network CIDR. So the IPv4 CIDR range on the customer gateway, this is the on-prem side. So again, this is 192.168.0.0/16. The remote IPv4, it's 10.0.0/16. So this is the AWS side, and looks good. I'm not going to change anything. I'm just going to go ahead and create the VPN connection. So this needs to be in available state, and we can see the tunnel details. Currently it is down, both the tunnels, the route, static route. You can see that we have added the AWS CIDR range and the on-prem CIDR range. So this is the outside IP address for the virtual private gateway. Tunnel 1 is the public IP address, and for tunnel 2, this is the virtual private gateway public IP address for tunnel 2. If you remember, virtual private gateway is a highly available device. It's created on two AZs. It has two endpoints. So we will create two tunnels. For tunnel 1, this is the IP address, and tunnel 2, this is the public IP address. This needs to be in available state. It will take some time. I'm going to pause the video and come back once the VPN connection is in available state. Before that, let me quickly show you that virtual private gateway. It's attached. So let's switch back to site-to-site VPN connections console. I'm going to pause the video and come back once it is in available state. Okay, I'm back now. The AWS on-prem VPN connection is been created and the status is in available state now. And I already showed you the tunnel details. And we have two tunnels and both are down and we need to configure it. I'll walk you through the process. And the static route is here. For the details, that the local IPv4 CIDR and the remote IPv4 CIDR. So everything is here configured. It is in available state. Let's go ahead and configure it. For that, we need to download the configuration. For the vendor, I'm going to use Strong Swan, and it's a Ubuntu. Already we have created the on-prem router as a Ubuntu server, and we can use anything above 16.04. I'll show you we have created the latest version. I'll show you that one, and the software is a Strong Swan 5.1 plus. It's anything, but we'll install the latest one and I'll show you. Let's download this. And let me go ahead and open the file. So this is the configuration file that we have downloaded, and let's go ahead and configure it. So let me keep this on the left here, and I'm going to use the xterm. I'm going to create a new terminal, and I'm going to SSH into the on-prem router. For on-prem router, let me get the on-prem router IP address. So this is the public IP address for on-prem router, and let me this is fine. Let me SSH to this one. The username is Ubuntu. And we have created, now we have logged into that Ubuntu. And let's get the configuration file. Okay, yeah, that's on the left here. Let's go ahead and configure it. But before we do that, let's install Strong here. Let me switch to the producer. I'm going to install the Strong. So we are installing Strong 5.9.13. So the latest version, that's fine, good. But this configuration file, it says like, it has been tested on 5.5.1 version, and we are installing the latest one. I have already tested it, it will work. I'll show you. So now let's open the etcctl.conf file and then do this configuration for. Let's start with the IPsec tunnel 1 here, and we'll follow the steps that's highlighted here. Let's open this file. We need to uncomment this line, net IPv4 IP forward. I've uncommented it, net IPv4 IP forward, saved, and we need to apply the changes in step 1, that whatever we did using this command. Next, we need to log into this file ipsec.conf, and we need to uncomment this line unique IDs 0. So I'm doing this one here, this configuration, and next we need to add these entries on this file. If you remember left subnet and then the right subnet, it says 0.0.0/0. Let's change this one. Left subnet ID, this is on-prem 92.168.0.0/16, and for the right subnet, the AWS side, 10.0.0/16. And now let's copy this one. You don't have to make any changes here. We have to uncomment this one, like if you want to use the script for automated tunnel health check and failover, we are not going to do it. We will do the configuration manually. I'll show you this one. So let's go to the end of the file. Paste everything here. So the left ID, that's the, if you see here, I'll keep it in the middle here. Okay, so this is the on-prem router public IP address. It's 52.39.9.218. So this one, and the right one, if you see, I'll minimize this one a little and show you. If you go to tunnel details here, so it says like 23.23.67.213. That's the one, 23.23.67.213. So this is the public IP address for the tunnel 1 for the virtual private gateway. And that's good. And let's just keep this configuration file open. Just maximize it again. And this one is good. Let's go ahead and save this configuration file. And next, let's go to, we need to create a file, or this file is already available because we installed strong one. So let's go ahead and etc/ipsec.secrets, and we need to add the secret for the authentication. This is the value that we need to add for authentication. This is to authenticate tunnel 1 from our customer gateway to the virtual private gateway tunnel 1. Careful about the spacing and everything. Just copy this exactly from your configuration file. Next, and we need to configure the route based tunnels manually. I'm going to do it manually. I'm not going to do the script, so I'll walk you through this process now. Here for this one, we need for the local IP address. If you see that, like, if the device is in a VPC or behind a device that's performing an NAT, network address translation, we need to use the private IP address. We cannot use the public IP address. So this is the public IP address of the on-prem router, but on-prem router is actually behind a NAT device, that is internet gateway. So the public IP address is translated at the internet gateway level. We need to use the private IP address for the on-prem router. So this is the on-prem router. If you remember, this is the public IP address. We don't want that. We need to use the private IP address here. And I'm going to change this one. So that's 192.168.4.6.49. So I'm going to copy this one. Execute it. So the next one, there's no change, we can execute it as it is. And execute the third line also. Okay. Now we need to add this route. So VPC CIDR, we need to use the VPC CIDR here. That's 10.0.0/16. Done. And next we need to open this file and make the modifications. Let me open this one, and we need to uncomment this line install routes from yes. I need to change that also from install route from yes to no. By default, the strongs one will create a routing entry in a different route table at launch time. So to disable this, we need to make these changes. So let me change search for install routes. Okay, I uncommented it and then change from yes to no. Okay, I've done. Save this file. We have completed this step, and next we need to configure the IP tables. For that, we need to use these two lines. Next one. Okay, it's done. And we need to make one more modification at the sysctl level. So let's open this file again. And add this in the end. So here for the physical interface, it's ENX0. So let's change that one here. Changed it, and let me copy all this here. Let me go to the end of the file, add it. Okay, so if you remember, okay, I can show you. We need to install net tools. Now you can use ifconfig. If you see, ENX0 is the interface here that has the private IP address for this router. So we need to execute this command, to apply these changes. Let's do this. So we had done with the configuration for tunnel 1. If you want to make this configuration persistence across a reboot of the router, we can do this step 5, but I'm not going to do this for this demo, and it's straightforward. You can use this one, and I can follow the process here. First, let me see if the IPsec status. We don't have a tunnel up. Let's restart the service. We have restarted, and if you see the tunnel, it's up and running. So if you go to the VPN connection, it should come up from status from down to up. It will take some time. In the meantime, let me go ahead and make one changes on the on-prem router that's disabling the source and destination check. This is the router. Go to networking and then change source destination check. The source destination check ensures that the instance is the source or destination of all traffic it sends and receives. But this is it's a router device. We are configuring as a router, so it should pass or send the traffic through. This is not the destination or the source. If you remember, this is similar thing that we used to do in the earlier days, like when we had a NAT instance before the NAT gateway comes into play. So when we configure the NAT instance, we want to disable the source and destination check. So this is similar to that. So we have to disable the source and destination check on the on-prem router instance. Remember the Ubuntu server where we have installed and configured the StrongSwan VPN. Remember to disable that source and destination check. So it's good. It stopped. And let's go back here quickly and see if the tunnel is up. But when it is coming up, let's go ahead and do the route table configuration. Let me go to route tables. So let me go ahead and enable the route propagation. We can enable the route propagation for all the route tables for this VPC, or if you want to propagate only the routes from particular subnets, we can do that as well. So I have created the Aurora database on the private subnet, that is private 3 and private 4 subnet. So I'm just going to do the route propagation only for these route tables, the subnets that is associated with this the private 3 and private 4 subnets. I don't have to, but if I need, I can enable the route propagation for the other route tables. If you need to access the private EC2 instance, I have created the private EC2 instance on private 1 subnet, and then I have this route table that is associated with that subnet. But for this demo, I'm going to show you how to access the database. So let's go ahead and do the route propagation. Select private 3 route table, and then the subnet, that is the private 3 subnet that is associated. And if you go to routes, currently we have only 2 routes. So let's go and edit this one, route propagation, and enable the route propagation. Now if you see the route, we have this route for the 192 network, that is our on-prem network. So that goes through our virtual private gateway. So let's go and enable the route propagation for the other route table also, that is private 4 route table. That's the private 4 subnet is associated with that one route. So we have 2 routes. Go to route propagation, edit route propagation, and enable. So we have enabled the route propagation for the subnets, for the route tables that has a subnet 3 and subnet 4. Now let's go to on-prem side. So this is the Oregon region, and I need to do the route propagation. For that, let's go to VPC, go to route table. I have a route table that is on-prem DC route table. We have only one subnet, so one route table here. And if you see the routes, we have 2 routes. And if we can go to, we cannot do the route propagation here because we don't have a virtual private gateway. So we are going to edit the route and add a route. So this is the on-prem side. So to reach the AWS side, that is 10.0.0.0/16, and we can select the instance and then select the on-prem router, or we can select the network interface and then select the network interface that is attached to the on-prem router. So I'm going to select instance and then select on-prem router. So any traffic that needs to go to the AWS side for 10.0.0.0/16 network, it will go through the on-prem router. That's the system, the Ubuntu server where we have configured a Strong-Swan VPN. Save. We have updated the route table now on both AWS and the on-prem side. Next, we need to update the security group rule. For access the Aurora database, I'm in EOS East 1 region. We go to instances, we go to security group. I have a security group that's created for Aurora DB. If you see, it has an inbound rule. Currently, it accesses the MySQL Aurora connection on port 3306 that comes from the security groups that is attached with a private EC2 instance. So you can see that that's highlighted. So that's the security group that is attached to private EC2 instance. So if any instance that has this security group can connect to the Aurora database using port 3306. Now I'm going to edit and add another rule here. I'm going to select again MySQL Aurora. I'm just going to leave it as anywhere because the Aurora database is not publicly accessible, and it's not. Even though if I leave it here, we cannot access it from the public internet. We can access it only from the private, from the VPN connection. So I'm just going to do this one. Saved it here, and next we need to update the security group on the on-prem side. So now we are back in the Oregon region. Let me go to security group here, and I need to update the on-prem router security group. Add a rule, and again I need to do it for MySQL Aurora. I'm going to leave it as anywhere. Save the changes. This is good. So we have updated the route table and the security group and everything. So now let's connect to the on-prem server and see if we can access the MySQL database that is on the AWS side. Before that, let's see, we can go here and go to VPC and see the VPN site-to-site VPN connections. Refresh it here. Yep, tunnel 1 is up. So let's go ahead and do the tunnel 2 configuration also, and then we will see, we can see how we can access the database. So we're good here, and let me open the configuration file. Okay, yeah, let's configure IPsec tunnel 2 here. So we have already completed this step, so we don't need to make this change, and it's already done. Now let's go, and for this one, this particular step also we have already completed, so we don't have to do this, but we need to add these entries here for tunnel 2. So let me go ahead and change this left subnet and the right subnet also here. If you remember, left subnet is the on-prem one. It's 192.168.0.0/16. And the right subnet, it's 10.0.0/16. Let me copy this. Open. Second file. We are in the end. This looks good, and if you remember, this is the router IP address here. If you go to the instances, on-prem router, this is the public IP address for the router. It's 52.39.92.18. That's the on-prem router IP address, public IP address. And go back to this VPN connection here, and tunnel 2, this is 35.170.181.40. So that's the public IP address for the virtual private gateway on tunnel 2. So everything looks good. Let me go ahead and save this configuration file. And next we need to add the authentication key here. Let's open ipsec.secrets file. Add this entry. This is for the authenticating the tunnel 2. Looks good. And next I'm going to do this interface configuration manually. And if you remember, here again we need to do this local IP. That's for the on-prem router, but the private IP address. Next, let's do this. Let's execute these commands. And we need to do that route add. Let me change this VPC CIDR. That is 0.0/16. Good. And we have already did this modification on the strong one file. We already did this one. So now we need to do the IP tables configuration. Let's go ahead and execute this one. The next one as well. That's good. Now let's do the final changes here for sysctl, and if you remember physical interface, it's enx0. That looks good, and let me copy this off. Let me open etc ctl.conf. Let me add this here. Apply these changes by running ctl -p. Good. Okay, now we don't again I'm not going to do this persistent configuration for tunnel 2 as well, and you can just follow these steps. It should be straightforward. Now if you see that IPsec status, we have only one tunnel. I'm going to restart again. So now if you see, we have two tunnels. We have tunnel 1 and tunnel 2, both up and running. We don't need this configuration file. And if you go back to that AWS on-prem VPN connection, and the tunnel 2 should come up soon. It would take some time, but we can, it takes some time to refresh, but it's already up and running. I've shown you here. Both the tunnels are up and running here. So let me go ahead and see if we can access the Aurora database from the on-prem server. So let me open a new terminal and let me go to the on-prem server that's created on the Oregon region. Let me copy the public IPv4 address, and I'm going to maybe maximize this one here. It's an Amazon Linux, so it's easy to use. It's good, and we need to install the MySQL client for that. Let me install the SQL client. Okay. Now let me go to super user anyway. Okay. Then MySQL. Let me get the endpoint back here, and if you go to East 1 region in the RDS, I'll copy the endpoint. Let me give the port first. It works. And let me show databases. Switch to company. So tables. Yep, we have all the three tables. And Yep, it works. And then now we have created the site-to-site VPN connection and access the Aurora database that is not publicly accessible. I can show you here. So this is not publicly accessible. This is on the AWS private subnet, and we have created the AWS site-to-site VPN and accessed from the on-prem server this particular database, and it works. We don't need any Bastion host or jump box or EC2 private, EC2 instance, anything. So this is how it is easy to access the AWS VPC resources from the on-site data center. In this video, I showed you how to create AWS site-to-site VPN and access AWS VPC resources from on-prem data center. So this is the architecture that we have implemented in this video. I hope you have learned something out of this video. Please subscribe to my channel for more AWS related contents. Thank you. Bye.